Welcome to another episode of VoxAI News. I'm Alice.
And I'm John. Today we're diving into a fascinating topic, high-resolution image synthesis with latent diffusion models. This is a cutting-edge area in the field of computer vision.
Absolutely, John. It's incredible how far image synthesis has come, especially with the advent of diffusion models. Can you give us a brief overview of what diffusion models are?
Sure, diffusion models are a class of generative models that learn to create data by gradually denoising a random noise input. They work by simulating a diffusion process, where data is progressively refined to produce high-quality images.
That sounds interesting. How do these models achieve such high-quality synthesis?
They achieve this by leveraging a hierarchy of denoising autoencoders, which sequentially refine the noise into a coherent image. This process allows them to capture complex distributions of natural images effectively.
I see, but I understand that training these models can be quite resource-intensive. Can you elaborate on that?
Definitely. Training diffusion models often requires hundreds of GPU days due to their complexity. This can make them inaccessible to many researchers and developers who might not have access to such resources.
That's a significant barrier. So how do latent diffusion models, or LDMs, aim to address this issue?
LDMs tackle this by operating in a latent space instead of the pixel space. By doing this, they reduce the computational complexity while still retaining high-quality outputs. This is a game-changer for accessibility.
Interesting. What exactly is meant by latent space in this context?
Latent space refers to a lower-dimensional representation of the data that captures the essential features without the noise. In the case of LDMs, a pre-trained autoencoder creates this representation, making the training and inference processes much more efficient.
So this means that LDMs can generate high-resolution images without the heavy computational load typically associated with diffusion models, right?
Exactly. They manage to strike a balance between complexity reduction and detail preservation, which is crucial for visual fidelity.
Can you explain how LDMs improve upon traditional diffusion models in terms of image quality?
LDMs introduce cross-attention layers, which allow the model to consider various conditioning inputs, such as text prompts or bounding boxes. This flexibility leads to better control over the image generation process.
That sounds powerful. What kind of tasks can LDMs perform effectively?
LDMs excel in several tasks, including text-to-image synthesis, unconditional image generation, image inpainting, and even super resolution. Their versatility is one of their strongest features.
What about the performance metrics? How do LDMs compare to other models in terms of quality?
In terms of metrics like FID scores, LDMs have achieved state-of-the-art results, outperforming many previous models, including GANs and other diffusion models.
That's impressive. Can you tell us more about the training process of LDMs?
Sure. The training process is divided into two stages. First, an autoencoder is trained to create the latent space, and then the diffusion model is trained in that space. This separation allows for more efficient training and better quality outputs.
How do LDMs handle the challenge of generating high-resolution images?
LDMs can generate high-resolution images by using convolutional techniques in the latent space. This allows them to render large, consistent images efficiently.
What are some of the implications of making high-resolution image synthesis more accessible?
Democratizing access to these models can lead to a surge in creative applications, from art generation to practical uses in industries like advertising and entertainment. However, it also raises ethical concerns.
Speaking of ethics, what are some potential societal impacts of generative models like LDMs?
Generative models can be used for both positive and negative purposes. While they enable creativity, they can also facilitate misinformation and deep fakes, which pose significant ethical challenges.
That's a crucial point to consider. How do researchers ensure that these models are trained responsibly?
Responsible training involves using diverse data sets and implementing fairness checks to mitigate biases that may be present in the training data. Transparency in the training process is also essential.
What does the future hold for latent diffusion models and their applications?
The future is bright. As computational resources become more accessible and models continue to improve, we can expect to see even more innovative applications in various fields, including healthcare, design, and entertainment.
Before we wrap up, can you summarize the key points we've discussed today?
Certainly. We explored how latent diffusion models enhance image synthesis by operating in latent space, improving computational efficiency while maintaining high quality. We also discussed their various applications and the ethical considerations surrounding their use.
Thank you for that comprehensive overview, John. It's been a pleasure discussing this exciting topic with you.
Likewise, Alice, it's always great to delve into these advanced technologies. Thanks for tuning in, everyone.
Thanks for joining us. Stay curious and stay informed. We'll catch you on the next episode of VoxAI News.